Assalamualaikum and good day to everyone. Today we are from Group 6. We are honored to present our technology design project titled Remote Control River Cleaning Boat, which was conducted under the supervision of Dr. Azun Aida binti Buhari. This presentation will cover all about our project, so we will begin now. Okay, so here is our team. So this project was carried out by Group 6, which consists of 5 members, Arfan Hilmi, Natasha, which is me, Amir Hakimi, Khadijah and Lokman. So each member contribute to different component of project, including system design, hardware, software integration, prototype and testing and so on. So each of us will be presenting our own section to explain the full process of how the project was developed and implemented. So my name is Nur Nafisa Natasha binti Hizam Shah. My matrix number is CN240459. I will present about introduction of our project. So in Malaysia, rivers are essential resources that support various aspects of life, from economic activities such as agriculture and transportation to environmental sustainability and public well-being. However, river pollution has become a growing concern, especially in areas close to resident and urban development. Uncontrolled waste disposal has led to accumulation of floating waste, particularly plastic and rubbish. This not only affect water quality and aquatic life but also increase the risk of flash flood when the waste block the natural water flow. Currently, river cleaning is still done manually using basic tools and small boats, which require a lot of physical effort and time. Moreover, this manual approach put workers at risk when operating in pollute and unsafe water conditions. So to address the issue, our project focused on applying engineering principles to develop a remote control river cleaning boat. The aim is to introduce a more efficient and safer method to support river cleaning activity. By using a motorboat with a waste of collection system and remote control operation using Blink, we hope to reduce the reliance on manual labor while improving the clean and effective in smaller river section.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Luqman Azad Arif. My matric number is CN240047. For the slide is about objective. We know its objective. We have 3 objectives to claim. For example, to design a remote control river cleaning boat applicable to collecting float waste such as plastic bottle, leaf, and material other debris from the water surface, efficiently to develop a user-friendly and cost-effective system that ensures water wave cleanliness while reducing the need for manual labor and improving environmental sustainability. Lastly, to test and verify the performance of the proposal both through a prototype setup under the rule of simulation river collection.
Okay, next I will explain the scope of our project. So the scope of our project is focused on building a small-scale prototype to demonstrate the concept and functionality. The boat is designed using PVC pipe and 2mm acrylic sheet, which provide both structure and buoyancy for the system. Next, the main function of the boat is to collect floating waste such as plastic and leaf using a conveyor mechanism that recycle. Installed at the front, this conveyor has a limited capacity and only targets surface waste, so it is not capable of collecting submerged or heavy debris. For the control system, we use ESP32 microcontroller and connect it to a smartphone through the Blink application, which allow us to control the boat wirelessly. The boat can be moved forward, backward, left and right, and the conveyor can be turned on or off through the app. Power is supplied by rechargeable lithium-ion battery, which provide electricity to the ESP, motor driver and 2 DC motor. However, since the connection is based on the Bluetooth, the control range is limited to around 10 to 50 meter, making it suitable only for short distance and small area testing. The scope allows us to focus on developing the core functionality of the system, test its operation in controlled water environment and demonstrate the potential of using this type of design for future improvement and real-world application.
Hi and Assalamualaikum. My name is Khadijah Maintul Aman and my matrix number is CN240428. Now, I will explain the problem statement for this project. In Malaysia, especially in city areas, river pollution is a serious issue. Large amount of rubbish like plastic bottles and food packaging enter our rivers. This affects the water quality and harms aquatic life. When this waste piles up, it blocks the water flow. This situation often causes flash flood during heavy rain. At present, most river cleaning still depends on people doing it by hand. This manual method takes too much time and is physically demanding. It also exposes workers to dirty and unsafe water. Furthermore, cleaning by hand is not effective for large or hard-to-reach locations. Therefore, we need a safer and more efficient way to collect waste and reduce the risk to human workers.
Now I will represent our literature review of our project. Previous study showed the water surface cleaning robot mainly focused on motor, controller, microcontroller and waste collection system. DC motor are commonly used because they are low cost and easy to control, while BLDC motor are more efficient but more complex. In microcontroller such as Arduino Uno, ESP32 and Raspberry Pi are widely used. ESP32 is preferred due to its wireless capability and lower power consumption. On common waste collection method include conveyor belt, pedal, net and suction system. However, many existing designs are complex, expensive and have a short battery life. Therefore, the research is gap existing for a simple, low cost and energy efficiency water surface and cleaning robot suitable for a small scale environment. That is our literature review for our project.
Hai, Assalamualaikum warahmatullahi wabarakatuh. My name is Luqman Azad bin Arif. My metric number is CN240047. For today, I would like to present is about methodology summary. This project adopt a system development approach involving system design, hardware, software development, and performance to construct a remote control river cleaning boats. The system is centered on ESP32 microcontroller, which process wireless command from mobile phone and control population and cleaning mechanism via an L29AN motor driver and relay module. The mechanical structure is built using a alkaline and PVC material to ensure lightweight construction, biofence and water resistance. A conveyor based waste collection mechanism is interact in front of the boat to lift float debris into an internal storage compartment. Dual DC motor provide propulsion and forward, reverse and turning movement such as left or right. Software development is implemented using the Arduino IDE with C or C++, while the Blink mobile application enable Bluetooth-based remote control. System testing and evaluation confirm function, stability and responsive all components. Overall, the methodology ensures reliable integration of mechanical, electrical and software systems to achieve the project objective efficiently.
Now I will explain the result of our project. During test, the river cleaning boat worked well and stayed stable in water. The boat could move smoothly and did not sink or tilt. The conveyor system successfully collecting floating waste such as plastic bottle and leaf. We found that the longer the system operates, the more trash is collected. Based on our finding, the maximum trash is collecting was 5.6 kilo. The motor worked smoothly when the battery level was high. but when battery level become low, the motor speed decrease slightly. This show that the battery level affect the system performance. The boat was controlled using a Blink application. It responds quickly within short distance and work well up to 200 meters. After that, the connection become unstable. Overall, this complete all component work properly, and the project achieved the objective that we try to explain.
Hi, my name is Muhammad Amir Hakimi. Today I will explain about a recommendation. For our first recommendation, we suggest integrating semi-autonomous feature into the system. Currently, the boat operates fully under manual control using a smartphone application, which is Blink. By adding simple sensors such as ultrasonic or infrared sensor, the boat can automatically detect obstacles or floating waste. This improvement can reduce operator workload, improve cleaning efficiency, and make the system safer during operation, especially in areas with limited visibility. The second recommendation focuses on improving power management and battery efficiency. At the moment, the system relies fully on lithium-ion battery. Future improvement could include better power regulation, low power operating mode, or even the integration of small solar panel. This would allow the boat to operate for a longer period, reduce frequent battery charging, and make the system more suitable for real-world river cleaning application. The final recommendation is to enhance the waste collection capacity and mechanical design. The current conveyor and storage system work well for small-scale cleaning, but its capacity is limited. By improving the conveyor strength and increasing the size of storage compartment, the boat can collect more waste in a single operation. This enhancement would make the system more practical for longer river and longer cleaning tasks. That's all from me. Thank you.
To conclude their presentation, this project is a success because we achieved all our research goals. Our testing proved that the boat is very stable on the water and the conveyor system can collect floating waste effectively. Technically, the ASP32 and motor driver provide very reliable wireless control throughout the testing. We also use 2.5mm PVC and 2mm acrylic sheet to ensure the structure is strong enough to carry a heavy load of rubbish without sinking. In summary, this design provides a practical and low-cost solution to help keep our rivers clean while significantly reducing the need for dangerous manual labor.
Next, for the reference, this project is supported by a total of 21 academic and technical sources. This reference includes journal article, conference paper, technical report, and online resource related to river cleaning system, microcontroller application, motor control, and IoT-based technologies. All references were carefully selected to support the design methodology, component selection, system implementation, and performance analysis of this project. By referring to reliable and relevant sources, we ensure that the development of the remote control river cleaning boat is based on proven engineering concept and current technological practice. That's all from our group presentation. Thank you.